Diamond rain on Neptune and Uranus. Diamonds may be a girl's best friend on Earth, but they fall from the sky in Neptune and Uranus. These planets have such extreme pressures and temperatures that carbon atoms compress and crystallize into diamonds, which fall from the sky. While this phenomenon has not been witnessed in person, scientists have been able to simulate the parameters of these planets' upper atmospheres to confirm that diamond rain is a realistic possibility. Diamond formation on Neptune and Uranus is assumed to originate in the planet's mantles, where heat and pressure break down methane and other hydrocarbons. This causes carbon atoms to become released into the upper atmosphere, then exposed to deathly cold temperatures and intense pressure. Carbon atoms are said to compress and crystallize into diamonds under these conditions, which eventually fall through the atmosphere toward the planet's core. Diamonds formed on Neptune and Uranus are estimated to be significantly larger than those found on Earth, with estimates ranging from millions to billions of carats. These diamonds, however, are located at depths of several thousand kilometers, rendering them inaccessible to humans or contemporary technology. Methane rain on Titan. Titan, Saturn's largest moon, is the only moon in our solar system with a significant atmosphere. Titan is a one-of-a-kind moon in our solar system, with a thick atmosphere and a weather system powered by methane rather than water. Titan's extreme cold, with temperatures as low as minus 290 degrees Fahrenheit, permits methane to exist in liquid form, similar to how water exists on Earth. Methane rain on Titan begins with the formation of methane clouds in the atmosphere. These clouds resemble Earth's water clouds, except they are made up of tiny methane droplets rather than water droplets. As they become denser, methane rains onto the moon's surface, forming rivers and lakes of liquid methane. One of Titan's most fascinating features is Kraken Mare, the moon's largest lake. This lake is roughly the size of Earth's Caspian Sea and is filled with liquid methane. Scientists believe that Titan's methane rain, coupled with other geological processes, is responsible for the formation of this massive lake. The discovery of methane rain on Titan has piqued the interest of scientists looking for evidence of life beyond Earth. The existence of methane on Titan and other organic molecules suggests the possibility of life on this moon. However, more research is needed to fully comprehend Titan's complex chemistry and geology before any conclusions can be reached. Lava oceans on Io. Io is one of Jupiter's biggest moons and the solar system's most volcanically active object. Over 400 active volcanoes can be found on the moon, with some spouting lava fountains reaching heights of over 300 kilometers. The lava oceans that exist on Io are the result of these eruptions. The lava oceans on Io arise because of the extreme heat generated by the moon's volcanic activity and its proximity to Jupiter. Jupiter's gravitational pull causes tidal heating on Io, resulting in intense pressure and heat within the moon's interior. This melts Io's mantle, which results in a steady flow of molten lava on the surface. The lava oceans on Io are said to be a mixture of sulfur and silicate rock, which emits a vivid yellow-orange glow visible from Earth. The lava also releases chemicals like sulfur dioxide and sulfur monoxide, which contribute to the moon's thin atmosphere. Despite the harsh conditions on Io, scientists have gathered vital information on the moon's geology and the processes that cause its volcanic activity. NASA's Voyager 1 probe was the first to observe the lava oceans on Io in 1979, and subsequent missions have supplied more comprehensive information about the moon's surface and interior. While Io's harsh conditions make it unfriendly to life as we know it, it provides significant insights into the complicated geological processes that build worlds beyond our own. Frozen volcanoes on Triton. Triton is Neptune's largest moon and is known for its peculiar geological features, such as the existence of frozen volcanoes. Unlike Io's molten lava oceans, Triton's volcanoes erupt a mixture of frozen nitrogen, methane, and dust, creating a cloud of material reaching a height of up to more than 5 miles. Triton's frozen volcanoes are assumed to be caused by a mix of factors, including the Moon's freezing temperatures, peculiar orbit, and the concentration of volatile compounds on its surface. The Moon's temperature can plummet to minus 235 degrees Celsius, causing the volatile chemicals on its surface to freeze and solidify. Triton's frozen volcanic activity begins with the accumulation of pressure and heat within the Moon's interior. As this accumulation rises, frozen nitrogen, methane, and dust are released from the volcano, forming a plume visible from space. These eruptions also leave dark streaks on the surface of Triton, which is said to be deposits of dark material left behind after the volatile substances have evaporated. The study of Triton's frozen volcanoes reveal vital information about the composition and dynamics of the outer solar system, where conditions differ so much from those on Earth. Supersonic winds on HD 189733b. HD 189733b is a gas giant exoplanet in the constellation Vulpecula, approximately 63 light-years from Earth. It is notable for the presence of supersonic winds in its atmosphere. The extreme temperature difference on HD 189733b causes supersonic winds, with the day side of the planet reaching temperatures of up to 1,000 degrees Celsius. Because of the intense heating, the atmosphere on the day side expands and rises, resulting in a high-pressure system. As a result, the night side atmosphere rushes to fill the low-pressure system, resulting in a strong and fast-moving wind. The wind speed on HD 189733b is estimated to be up to 8,700 km per hour, or roughly 10 times the speed of sound. As a result, HD 189733b is one of the most extreme exoplanets discovered to date. Twin suns on Kepler-16b. In the Star Wars universe, planets with twin suns are common, though they are much rarer in the real universe. Kepler-16b is an exoplanet in the Kepler-16 system, around 200 light-years from Earth. It is famous for being the first planet identified to orbit two stars in a circumbinary orbit. This means that the Kepler-16b revolves around two stars instead of simply one, giving the appearance of twin suns in the sky. Kepler-16b orbits a pair of smaller stars known as a binary star system. These stars are both smaller than our Sun and orbit each other very closely. Kepler-16b, on the other hand, orbits these twin stars from afar, taking 229 Earth days to complete one orbit. Kepler-16b's twin suns make an unusual and fascinating spectacle in the sky. As the two stars rise and set at different times, the planet experiences alternating periods of daylight and night. This produces a distinct pattern of light and shadow on the planet's surface, as well as specific weather patterns and temperature variations. Glowing nights on HD 2094-58b. Every night sky on Earth is almost always gloomy, save for the stars and occasional aurora borealis. The night on HD 2094-58b, an exoplanet roughly 153 light-years away from Earth, are anything but dark. HD 2094-58b is an exoplanet in the Pegasus constellation. It is known for its remarkable feature of glowing nights, which are created by a process known as thermal inversion. Thermal inversion happens when a planet's upper atmosphere becomes hotter than the lower atmosphere. This is the opposite of what happens on planets when the lower atmosphere has a higher temperature than the upper atmosphere. The planet's proximity to its star causes the upper atmosphere to be heated by intense radiation, which generates this unusual temperature gradient on HD 2094-58b. The upper atmosphere of HD 2094-58b has a layer of hot gas that produces light in the form of a glowing night due to thermal inversion. Because of the presence of sodium in the atmosphere, this light is predominantly red, and this light on HD 2094-58b is predicted to be almost 80 times brighter than the full moon on Earth, and can be seen through telescopes. HD 2094-58b and its glowing nights provide vital insights into the complexity and diversity of planetary systems beyond our own. Iron Rain on WASP-76b. WASP-76b is a gas giant exoplanet in the constellation Pisces, approximately 640 light-years from Earth. It is notable for its one-of-a-kind feature of experiencing iron rain in its environment. Iron rain on WASP-76b is caused by a process known as condensation-induced atmospheric escape. This process occurs because of the planet's extreme temperature gradient, with temperatures on the day side reaching up to 2400 degrees Celsius. As a result, metals like iron vaporize into the atmosphere during the day and condense into liquid form throughout the night. This process results in the precipitation of molten iron droplets on the planet's night side. This precipitation is what we call iron rain. The iron rain on WASP-76b is estimated to be extremely heavy, with each droplet the size of a human fist falling at rates of up to 7 kilometers per second. The study of iron rain on WASP-76b sheds light on the genesis and evolution of gas giant exoplanets and the possibility of habitable worlds outside our solar system. Floating mountains on exoplanet Corot 7b. Corot 7b is an exoplanet that was discovered in 2009 by the French-led Convection, Rotation and Planetary Transit Corot mission. It is located about 489 light-years away in the constellation Monoceros and has a mass roughly 4.8 times that of Earth. In 2015, a team of researchers from the University of Warwick reported the detection of floating mountains on Corot 7b using computer simulations. These mountains are not composed of rock or soil like those on Earth, but instead are made of hot gas that has condensed into solid form due to the extreme temperature and pressure on the planet. Corot 7b is a so-called hot super-Earth because it is a rocky planet that is very close to its parent star, completing one orbit every 20.4 hours. This proximity means that the planet is subject to intense heat and radiation, causing its atmosphere to expand and create extreme temperature gradients that can lead to the formation of such mountains. As a result, the planet's atmosphere experiences intense convection, with hot gas rising and cool gas sinking. This convection causes the planet's rocky mantle to overturn, with large chunks of rock being lifted into the atmosphere. These chunks of rock then become suspended in the planet's atmosphere, forming floating mountains. The floating mountains on Corot 7b are estimated to be about 10 times taller than Earth's Mount Everest, with peaks rising to 8,000 meters above the planet's surface. They're thought to be composed of a mineral called corundum, which is also found in rubies and sapphires. And there you have it! Let us know in the comments section which of these phenomena you like. We hope you enjoyed this video and learned something new today. And as always, keep exploring!